And a warm welcome back. Today on the bench is the big green amplifier, which is, if I remember rightly, 6BG6GA push-pull 25-watt amplifier with a 12BH7E phase splitter and 6CL6 triode strut voltage gain stage, common cathode, blah blah blah. I'm in the process of getting all these amps sort of dialed in, sorted, so that I can flog them to make room, obviously, for other amplifiers that I want to build. But to build other amplifiers I need cash. To get cash I've got to sell the amplifiers I've already got. When I build the amplifiers, I mean, they're not thrown together, but it's like an iteration. So I design what I think is right, but as I do testing and listening tests, bench tests and listening tests, then tweaks are made, changes are made, I can see where I can improve on things, etc. So having got to this point now, I've sort of been checking it all out, make sure everything is soldering and all the rest of it, and I thought, right, well, let's bung it on the and do a few frequency tests, and this is what I found. Right, this is the right channel. We've got 0.6 volts RMS output, 2.4. Let's change the scale. Aha, see there, look. Right, if I do the time base and get a pointy stick, see there, that oscillation on the top of the sine wave. If I expand the time base again and then just turn the gain up a bit more, you can see it's getting unstable there at the top of the waveform, and that's sort of right. I'm there, I'm about 6 volts RMS, just starts about there, starts to break into oscillation. So reduce that down, and then I'm going to put you on the other channel now. The other channel does something more interesting. Oops, where are we? 6.5 volts. I'm gonna have to reduce the time amplitude again. Right, okay, we're clipping there, but you see that where it just sort of went. Right, earlier on it was doing something far more interesting. Right, okay, I know what I'll do. I'll just bung the amplitude input, amplitude 0.5B. Let's try that, see if that will do it. No, it won't do it now. Well, earlier on, as soon as there we go. That's what I'm after. See, the whole damn thing is oscillating. It's like it's on a fucking trampoline. It's like a fat lass on a trampoline. So we've got some instability. This amplifier is a little bit different to a lot of valve amplifiers that you see, whether they be commercial or otherwise, in that it has a solid state tone control before the valve amplifier. That solid state tone control isn't part of the feedback loop. So what I'm going to do, I'm going to take this out of the circuit, as it were, connect an input straight into one of the channels, take off the negative feedback, and then I'm going to do a load of tests, and at the end of it hopefully I'll have some idea of how to stop that instability. Right, to find out what's going off, I'm going to do a load of frequency sweep tests, plot it all on paper, and the main thing I'm going to be doing is testing at higher power outputs, and I'm going to be using capacitive loads as well, which should make things interesting. That's where you start to, obviously a capacitive load is hard for an amplifier to drive without it going unstable. I'm going to do those and then I'll see you back at the end, because it's really long and boring. Right, I've done one test at quick 0. Right, with 50 millivolts RMS in. I've done one test. This is my second sweep at a higher input voltage and a higher output voltage. Output voltage is about 8 volts RMS. At 20 hertz we've got 0 dB loss. However, frequency 100 hertz, it dips down there, so there's some sort of anomaly going off down the bottom end. Basically what I'm looking for with all this mucking about is anomalies at the extreme frequencies, at extreme low frequencies and extreme high frequencies in terms of audio range, 20 hertz to 20 kilohertz and above. Just thought I'd show you that. Right, I'm going to crack on because I really have to keep me, get my head around this shit. Okay, I don't know what the hell is going off here. I've never really seen anything like this, so it could be my test method, or it could be because the amplifier has got a lot hotter. I don't know, I'm not quite sure what's going off. So let me just run you past the, let me just get you zoomed in a bit. There we go. Where's my fucking pencil? So when I ran it with 50 millivolts going in and with an output of 2.5 volts RMS out, this was the frequency response I was getting. So nothing too bad, all the way out here to 50k. I then increased the input voltage from from 50 millivolts to 150 millivolts RMS, and then, as I showed you in that previous clip, we was getting this dip here. So this is the trace that I'm talking about. We were getting this dip here where it was at 0 dB at 20 hertz, and then we had, if I can just do, sorry, this isn't 100% accurate, something like that. And then when it got to 1k and I sort of moved up to about 2-3k, it just, the frequency response dropped off a cliff. Well, that is, yeah, that is highly unusual. I wouldn't, all the amplifiers, I mean, I've tested quite a few amplifiers and I've done quite a, bleeding hours and hours of testing. I've never really seen anything like that, although something is sort of ringing a bell in the back of my head. So I'm going to have a think about this one, let things cool down and test again. Here we are the next morning on this beautiful day in July 2024, trying to find out what the crack is with the dire frequency response of the big green amplifier, 6B G6 and all that. So had a bit of a sleep, obviously, and a bit of cogitating. It doesn't make sense. I would never have left this amplifier in that state, or I would have done something about it previously if I had had such a dire frequency response result. C, or is it B? It just doesn't make sense. I tested it in the morning, it was fine. Tested it a bit later, it wasn't fine. So I've just basically unsoldered one component, and these are the results. So as you see on the oscilloscope, we've got a sine wave output. This is 20 kilohertz. It's 4 3/4 divisions in amplitude high. I'm going to reach past you and knock it down to 1 kilohertz, and we're reading 1.75 volts RMS output. 1 kilohertz. Okay, it's gone up a bit, but we would expect that. So previously at about 2 kilohertz it was dropping off a cliff. So basically what I've got the oscilloscope, and the probe is connected to the anode of the first stage, which is a 6CL6 triode connected. So the first stage, and that's all we're reading basically, the input and the output. And we're also reading the output of the amp in total, if you're with me, so I'm not making much sense. So let's well, that's 1 kilohertz, we're reading 2 volts, RMS, frequency 5 kilohertz, and we're still at about 2 volts, everything's cushy. Now I'll solder oh god blimey, I'm talking like an American. Now I'll solder that component that I've just unsoldered back, and we'll have a look at the result. Right, here's the trace with that component put back in. Just going to turn the control. So at the moment we're at 20 kilohertz. I set it to 0 dB at 1 kilohertz, and now I'm reading minus 17.7 dB. Turn that control, and at 20 kilohertz I'm reading 0.5 dB. Now I should reveal all. Right, we're on wobble cam. Here's me input going in, and I'm just connected straight onto the control grid of the first voltage gain stage. And we've got here, we've got a coupling capacitor, and then that goes to a volume pot. As I turn that volume pot, try to pull back, and hopefully you can see. Turn it up. So what's happening is the volume pot and this input capacitor, the volume pot and this decoupling cap is acting as some sort of weird filter. We're putting the input here. If I disconnect this, everything's fine. If I connect this, then somehow it is attenuating the signal, and that's where we're getting the really adverse readings from. Right, this section of video is taken about 2 weeks later. Forgive if there's any huffing and puffing and heavy breathing and whatnot on this bit of the video. I've been really ill for 2 weeks, and I'm just sort of getting back on my feet. Not eating much for a week, had bronchitis, blah blah blah. Anyway, back to this bloody amplifier. Where was I last time? Right, what happened before was I'd managed to fix a small fault on this tone control. It was just a break in the pads on this board here. Fixed that, everything's working. I did a quick power test to see what everything was right, and it started oscillating at about 6 volts RMS. So obviously I did like a couple of sweeps looking for reasons why, and then I centered on the volume controls. Right, let's get into a bit of a detail of the layout of the amplifier. Right, I'll just draw a rough block diagram of the amp. So we've got an RCA in there, sort of thing. That goes into, let's call that the tone control section, bass, treble, and we've got the volume control, and then from there that goes into the first valve, which is a 6CL6 triode strapped. Right, the volume control, imagine that's your pot, one end's grounded, that's coming from the tone control here. Now then, doing a frequency sweep, everything's fine here, but when it comes out here it starts to basically the frequency drops after about 2 kilohertz, goes right down. Because of the tone controls I can compensate for that, so in one way it doesn't matter, but in another way it does matter. So why the bloody hell is a frequency dropping off a frigging cliff like that there? And I'm pretty damn sure it's because the tone control hasn't got enough, it's got the wrong output impedance basically. This is a 1 meg pot. Shouldn't really, it didn't need to be a 1 meg bloody pot really. I don't know why I put them in there originally. Well, I know why I put them in originally, because originally it was going to be a valve tone control. This is the problem with changing bloody things all the time. You're trying to catch up with your son. Any road. So 1 meg pot falling off a cliff there. So that's basically not got enough output impedance at the like say 2 kilohertz to be able to drive, you know. I don't know, there's something fucking going off. So basically what I'm going to do is I'm going to make a little bit of a buffer using an op amp, just a simple buffer, bung that on a bit of this board and see if that fixes the issue, and then we'll see. What is it done? Right, I've made the little op amp buffer very simple. You know what an op amp buffer is, or you know, look it up. A couple of 1 meg resistors there on the inputs. So let's next just have a look at the problem on the old scope to give you an idea what the crack is. Right, on the screen there I've got a 1 kilohertz sine wave filling the whole of the screen. That's 4.3-ish volts RMS. That's on the input into the pot. Right, now I'm going to bung it up to 10 kilohertz. There's a 10 kilohertz sine wave. Now I'm going to move it to the wiper, and as you can see that is dramatically reduced in amplitude, which is not much cop at all. And subsequently the output of the amplifier has dropped to 1.3 volts RMS. So now I'm going to turn the amplifier off and everything, fit the buffer and see if that fixes the issue. Right, that's the buffer fitted, and I've just been testing it. Let's have a look. Right, hold on, let me just turn that up a bit. Well, hopefully you can see that okay. So we're at 3 volts, 5, we're at 9 there, and there's no parasitic or whatever oscillation. Everything's fine. Right, let's just knock that back down a bit there. Let's try that. Right, 7 volts RMS. Here's for the acid test. Just reach underneath here. Frequency 10 kilohertz. Hurrah! That's okay. So that's the right channel. Oh, left channel. Where are we? Okay. Right, that's 10 kilohertz. Oops. Okay, so we have got some loss there, which I don't quite know why, but it's a lot better than it was. Right, I'm going to call that done for the moment. I'm about at it for today. It's about 12 o'clock, starting to get hot. I need to have a sit down, still not out of the woods yet. But anyway, I'll bung that on, I'll As you can see, I can't really talk and everything, so I'm still a bit messed up. Anyway, you've not had anything to watch from me for a few weeks. I don't know how many weeks it is. So I'll get this popped up online. I've still got work to do. I've found that the, what do you call it? You can't see, can you? I found that the valve base underneath that lot is iffy. I'll try cleaning it first before I try replacing it, because it means pulling all of those off, which, yeah, I don't want to do. But apart from like tidying up a few things here and there and tidying wiring up, I think this amp is pretty much sorted. I don't know why it was doing what it was doing earlier on, and I can't be asked just at the moment to find out why. So thanks very much for watching. Take care of yourselves. Ta-da for now.